Alright, so in this video we're going to start talking about the basics. We're going to be talking about units and the metric system. So to start off with, we need to talk about the metric system. Most of you have probably heard about this before, but basically the metric system is a system of measurement that is most commonly used, and it provides us a way to consistently measure length, mass, volume, time, temperature. There's lots of different units. A more specific type of system is called the International System of Units, or the SI system. And this is a system that has been adopted by scientists. And for the most part, it's the same as a metric system, but not always. So for instance, we can see in the metric system, we measure length using the meter. And we also, in the SI system, we also use the meter. However, when we are using volume, metric system uses the liter, whereas the SI uses the cubic meter. Cubic meter is still a metric system. However, the base unit in the metric system is liter, where the base in the SI system is the cubic meter. So there's just little differences here and there. For mass, we can see the base unit is gram, but in the SI we have kilogram. In the metric system they use Celsius, the SI system uses Kelvin, and so there's just little differences here and there, but for the most part they're the same system. The importance of the metric system is set in multiples of 10, which basically means it's really easy to convert from one to the next because all you have to do is move the decimal. Unlike the English system where we have 12 inches in a foot, and then we have 3 feet in a yard, and so on and so forth. It's hard to, are we dividing by 12? How many ounces are in a pound? And how many, it's just really hard to convert back and forth because every single conversion factor is a different number. The metric system, it's all in 10. There is 10 millimeters in a centimeter. There's 10 centimeters in a decimeter. There's 10 decimeters in a meter. There's 10 meters in a decameter. There's 10 decameters in a hectometer. Everything is 10. So it makes it really, really easy to convert back and forth, which is a test question, by the way. Another importance of the metric system is it allows you to use the same prefixes to be used with all base units. In our system, we name everything different. So we have an inch, and then a foot, and then a yard, and then a mile, so on and so forth. Everything has a different name. In the metric system, they don't do that. When they're measuring distance, it's all using the meter, and they just add prefixes. So we have a millimeter versus a centimeter versus a meter and a kilometer. But basically they're all using the same, they don't change the name, they just add prefixes. That way they can, and they use the same prefixes with all of their base units. So a kilogram and a kilometer, kilo, it means that it's 1,000 times. It doesn't matter what the base unit is. There's 1,000 grams in a kilogram. There's 1,000 meters in a kilometer. Okay, it doesn't matter what the base unit, kilo means 1,000 times. Okay, so some of our common base units that we're going to be using in class is your meter, liter, gram, and seconds. All right, so here's those prefixes I was telling you about, and you guys need to write these down or print these out or something. This is also in your book, but we're going to be using these in the first lab, so hopefully you can refer back to them. But here are the main ones that we're going to be using in class. So we have kilo, hecto, deca, our base unit, which could be, like I was telling you a minute ago, meters, liters, grams. We have deci, centi, and milli. And each step is an increase of 10. So let's say our base unit, let's put a 1 next to our base unit. Okay, as we go down, we just add a 0. So that means there are 10 decimeters. There is 100 centimeters. There is 1,000 millimeters. So I just add a 0 as I go down. Okay, you add a 0 in the other direction as you go up. So this would be, there's 0.1. See how I'm adding a 0 onto the other side? Okay, but it just allows you, every single step in the metric system is an increase of 10. Okay, as you guys notice, you will also see some dashes. This is an unnamed prefix. Basically, after our main 6 prefixes that I was just talking about, after these 6, they stopped naming every step of the system because we didn't use them. We don't need a name for every single step. So they started going by every 3. And so let's, for instance, say we have 1 megameter. these are still serving as, they're like placeholders, okay? So there is 10, 100, there is 1,000 kilometers in 1 megameter, okay? They're just placeholders. They don't have names. They're just placeholders. Okay, so how to convert. This is how I convert, and I actually, if you do it this way, you can do it in your head relatively well. I'm going to show you another way as well that allows you to convert when we're not doing such easy conversions. But for when we're just going from centimeters to millimeters, so on and so forth, this is the really easy way, and it's called the ladder method. All you have to do is literally count how many steps you're skipping. So for instance, we can see here, if we go from kilo to our base unit, again, it could be meters, liters, grams. We could go from, we're going to go 1, 2, 3. We're doing 3 steps. We're moving to the right. When you convert to the right, you're going to move the decimal point to the right. So let's say we have 5 kilometers and we want to convert it to meters. Okay, all you're going to do is move the decimal point 1, 2, 3 times. So we're going to go, we have 5, the decimal point's right here, so we're going to move it 1, 2, 3 times, add zeros. So that means we have 5,000 meters. Okay, that's all you have to do to convert in the metric system. Count how many times you're moving and do it that way. Let's do the opposite way. Let's start with, let's say we have 25 centimeters and we want to know how many meters we have. Well, we're going to be moving 1, 2 times. We're going to move the decimal 2 times to the left. So if we're starting with 25 centimeters, we're going to move the decimal 1, 2 times. So then we're going to be left with 0.25 meters. Okay, not too bad. You just move it back and forth. Now, these are the 6 main prefixes that I was telling you about, but remember in the previous slide, I showed you a few other ones that you're going to need to know. So like after kilo, we had 2 steps, and then we had mega, and then we had 2 steps, and we had giga, so on and so forth. You're going to need to know more than just these 6 for the labs and for your tests, but these are the main 6, and these are the ones you're going to be using most of the time. Now, another way to convert is using something called a conversion factor. Now, if we're just converting between centimeters and meters, you can just move the decimal. But sometimes we have units that aren't the same. So like density uses grams per milliliter. And so the grams and milliliters are not exactly the same thing. And so you can't just move the decimal. Sometimes you have to use something called a conversion factor. So I'm going to show you both ways. Now, a conversion factor is just 2 equal measurements. They are the exact same thing. They just have different units. So for instance, we can say that 100 centimeters is equal to 1 meter. 100 centimeters and 1 meter, they're both a meter stick. It's the same thing. It doesn't matter if I say 100 centimeters or 1 meter. It's all the same amount. Or you could say 4 quarters equals $1. It's the same amount of money. One's paper, one's coin, but it's the same amount of money. And so that's a conversion factor. They have to be 2 equal measurements. They have to work together. A few other ones that you're going to need for labs is, for instance, 1 inch is 2.54 centimeters. They're the same amount of length. They're just different units. 1 kilogram is 2.2 pounds. You're going to need that for a lab when we're converting our weight. Again, same amount of weight, just different units. Another really important one that we're going to be using in lab a lot is this concept of 1 centimeter cubed is 1 milliliter. So if you have 50 milliliters of something, you have 50 centimeter cubes of something. 1 centimeter cube, think about a little sugar cube. 1 centimeter cubed, which is approximately the size of a sugar cube, is going to take up 1 milliliter of volume. Okay, and with water, 1 milliliter of water has a mass of 1 gram. Now, we can also use these conversion factors to convert, and we call this dimensional analysis, and I'm going to show you how to do that. But before we do that, we have to have a different way of writing this out. So for instance, when it comes to this conversion factor, I can write it as 100 centimeters over 1 meter, or I can write it as 1 meter over 100 centimeters. But these are conversion factors. We're taking our two equal measurements, and we're forming fractions. Two different fractions can be made out of each conversion factor. Now, which one are you supposed to use? So I'm just going to show you an example really quick and see if we can figure this out. So we're going to convert 2.35 millimeters to hectometers. So when I am doing dimensional analysis, you always write down what they're asking you to convert first. So they're asking me to convert 2.35 millimeters, and they're asking me to convert it to hectometers. So I need to multiply it by my conversion factor, but I need to know how many millimeters are in a hectometer. So let's think back to our conversion factors. So we had kilo, hecto, deca, and then we had our base unit. Then we had deci, centi, and milli. So we're wanting to go from millimeters to hectometers. So we're wanting to go from here to all the way down to here. So to do that, we're going to have to figure out what our conversion factor is. So if we put a 1 with our hectometer, and we add a 0 each time, so 1, 10, 100, and that one's going to be 1,000. This one's going to be 10,000, which is going to leave this one be 100,000. So we've added 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. So our conversion factor for this conversion is going to be, in 1 hectometer, we have 100,000 millimeters. Now, we have to form a fraction over this, and everybody's always asking me, well, how do you know which one goes on top and which one goes on bottom? In order to know this, you have to look at what's given to you. We have millimeters. Well, in order to convert to hectometers, we want to be able to get rid of our millimeters, which means it has to go on the bottom. If we divide millimeters by millimeters, then it cancels out. So we're going to put our 1 hectometer on the top and our 100,000 millimeters on the bottom. That allows our units to then cancel out, and we can then write our answer. So 2.35 divided by 100,000 is going to give us this many hectometers, which is a really, really small number. Now we need to think to ourselves, does this make sense? Well, a millimeter, you guys know what a millimeter is, it's relatively small. So if we only have 2 millimeters and we're trying to convert it to a much bigger unit like the hectometer, this answer makes sense. Okay, the next thing we're going to talk about is something called scientific notation. And scientific notation allows us to express really big numbers and really small numbers without any of the non-significant digits. Now we're going to talk about significant figures in the next video, but basically we're going to ignore the zeros. Okay, so when writing scientific notation, each number has 3 parts. We need a coefficient, aka a number. We need times 10 to some power, because remember, we're getting rid of the zeros. So if when we times things by 10, we're essentially adding zeros onto the end. So we are going to omit all of the zeros, and we're going to represent that by saying times 10 to this number. And then, of course, we need our unit. Now, when you are writing correct scientific notation, there can only be 1 digit to the left of the decimal. So keep that in mind. So let's look at this example. We have 267 with a whole bunch of zeros. Now, I don't know about you guys, but I do not want to count how many zeros those are and try to figure out if this is a million or a trillion, so on and so forth. So we're going to convert this to scientific notation. Now, like I said before, we can only have 1 digit to the left. So I want my decimal to be right here between my 2 and my 6, 7. Okay, so my decimal starts out over here. My decimal starts off at the end. Okay, so I'm going to want to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. Okay, so when I move it 11 times, we are going to have to then rewrite it as 2.67. Okay, there's our coefficient. Step 2 is we need to write down how many zeros we got rid of, and so we represent that by writing times 10. I moved the decimal 11 times, and since this is a really big number, this stays as a positive 11, and then I need a unit, which is centimeters. So basically, I'm communicating this number without all of those pesky zeros. It's a lot easier to read 2.67 times 10 to the 11th than to sit here and be like, okay, this is 267 trillion, so on and so forth. All right, now let's look at the next one because it's actually a really small number. So again, we can only have one digit to the left, so I want my decimal down here between the 5 and the 6. It's starting over here, so I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times. Since it's a really, really small number, we represent this with a negative 14 because we're not timesing it by 10. If we times things by 10, we're going to add zeros to the end. When you times things by a negative exponent, you're adding zeros to the left. Since all of our zeros are on the left, we have to represent that using a negative. So step 1, we need our coefficient. So it's going to be 5.6. Then we write our times 10. We figured out that we had to move our decimal 14 times. We're going to say negative 14. And then our unit is our nanoliters. So this is 5.6 times 10 to the negative 14th nanoliters. Okay, so just a little bit of practice, but what are the SI units for volume, mass, length, and temperature? So the metric system likes to use liters. The SI system likes to use cubic centimeters. Okay, the metric system for mass is grams. The SI unit for mass is kilograms. They both use meters. The metric system likes to use Celsius for temperature. The SI system likes to use Kelvin for temperature. Again, these are all metric units. It's just these two different systems have slightly different preferences, but we're going to be using them all in class.